Good afternoon. Absurdly Lovers, how are we? Another weekend coming up. Another weekend full of fantastic science, eh? Ice cores, just a quick one. The ice cores, okay? You know, they dig into the ice in Antarctica, they go down something like 4.6, 4.7 kilometers. I used to be a big fan of the ice cores. Those of you that have followed my shenanigans for a few years will remember me screaming, "It's in the ice cores, the Dansgaard-Oeschger cycles." It proves that planet Earth has had these monster spikes, like 25 of them in the last, I can't remember that now, how long was it? 25 in the last 40,000 years or something like that. I can't remember the exact number, but loads of spikes, boom, boom. Enough that it would prove that man-made climate change is a myth, because it's got these unexplained temperature spikes of up to 15 degrees Celsius over a decade, right? So boom, 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 and all of them over, 20,000 years or something. So it's gone up, stayed up, and then dropped, and then bang and bang. Now, I was a big fan of the ice cores because they proved that. But then it was about a year ago, because I came clean on this one, and as soon as I saw it, I thought, hang on a minute, how can ice cores prove that there have been temperature spikes of 15 degrees Celsius that have happened within a decade, right? How on earth do ice cores prove that? Because they've got 4 kilometers, right? It's 4.6, 4.7 in Antarctica. That's how deep it goes down. So this is the ground, right? The red. And then this is the first. So from the top down, 1 kilometer, 0.6 of a mile. All right, I'll put miles in for you as well. 2 Ks, 1.2 miles, 1.8 miles, 3 Ks. And then we've got 4 Ks. It's 4, 6, 4, 7, but I'm just going to stick with these for now. Now let's say and the timeline they give these, right? 1 K, 200,000 years. 2 Ks, 400,000, 6, and then 8 for 4 Ks down. That's really tiny. Really tiny, but it's ice. Okay, now so let's say, the first question, how on earth did they prove with ice cores that the temperature had spiked by up to 10 to 15 degrees hotter than it is now? Why on earth would that show up in the ice? Wouldn't the ice be melting? If it's that hot, the ice melts. So what is that? How? What is it in ice cores that says, hey, it's been 15 degrees hotter than you for the last 20 years? That's not going to show up in the ice, is it? Because it won't even be there. In fact, if it's that hot, we would have lost some layers as well, wouldn't we? So this is a little bit of a looking at what ice cores can tell them, or what they say. Even wind direction. So these ice cores that they dig out, right? Look, I've made some imaginary ones. What is it? What is it in an ice core that tells them all of this stuff? Hey, what is it? Is it something that goes down to the quantum level again, that only certain people can understand? Right? So this is a chunk of ice. This life size, right? Life size. We've got a chunk of ice. Right? And this is the actual size, right? And we've dug it up from, let's say, 3 Ks, right? 1.8 miles. Boom, we've gone down with our thingy, and we've got a chunk of ice. Now, what is it in that ice that's going to tell me what I need to know? It's not going to tell me anything about it being hotter than usual, is it? Because the ice wouldn't be there to start with, right? It will tell me what was in the atmosphere at the time this specific chunk of ice melted, wouldn't it? Right? How else would it work? Is it going to tell me what was in the atmosphere 6 months ago? And what was in the atmosphere 9 months before I melted? No, is it? So what it's going to tell us is what was in the atmosphere at the time it froze, right? That's it so far. It's ice. If you had a barbecue and you managed to freeze an ice cube next to the barbie and you stored it, it would have maybe particles of roast beef or, you know, burgers or something in there, right? But somewhere like this in the Antarctic, where all that's happening is whatever was happening, what is it in these chunks of ice that is telling them all of this information? Well, it's magic again, isn't it? It's magic. It's a piece of ice. I get that it will tell you what's in the atmosphere. But the direction of the wind? The direction of the wind. The temperature. If it was a hotter or cooler temperature, or colder than usual, or warmer than usual. How? It's snow. Snow comes down, sticks to the ground. It either freezes straight away or rain comes down over it, makes it all slushy, and then it would freeze, right? So what exactly am I missing here? It's definitely not going to tell me that the temperature was 12 degrees Celsius above usual, is it? Because if it was 12 degrees centigrade above usual when this froze, then we have to change the freezing temperature of ice, don't we? Because, so that is basically my question about ice cores. How can it tell them that planet Earth was going through a massive temperature spike, 10, 12, 15 degrees warmer than usual, yet this froze? Right. Now, I can understand this top layer, but not 100 meters of ice. I can understand the accuracy of some of the stuff that they might bring up that's near the surface, but surely when we're 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers deep, they are telling us that they know the age of the ice that they're bringing up from 4 kilometers deep. How? This radiocarbon dating. What is it? A half-life of uranium, was it 238? Has a half-life of 4.5 billion years. How do they know that? Who worked that out? How was it worked out? Surely to come up with something like that, don't you need to first experience the whole 4.5 billion years? Is it not otherwise speculation? Or do they have something that's smaller and maybe only have a half-life of 3 billion? And then they have something with a half-life of 1 billion. And then something with a half-life of 500,000. Something with a half-life of 250,000. And then 100,000, then 50,000. And then they start working out all these half-lives, and then they finally come up with this bizarre figure that, how do you prove it? How do you prove it? This is yet another example, right, of how they think they know all of this stuff, and I'm saying they don't, right? If, let's just say, for example, this was 800,000 years ago, right, when this bit here froze. No. Let's say this from 600,000 years to 400,000 years, right? Let's just say, for example, they got this more or less right. that from 2 to 3 k's deep, the ice started packing there between 4 and 600,000 years ago, right? Now, under the 600,000 years ago, who's to say that when it first started settling, right, say the first 200 meters, what if that happened about 500 million years ago, right? 500 million years ago, there was a cold patch, the first one that's ever been known on the planet, and it started to freeze, right? 200-300 meters, the first of the snow, and then it stopped because of the heat again, right? And it didn't lose, but it didn't gain, and it stayed like that for 3 million years, right? And then, it started to settle again, and then it went up another 200 meters, right? And then there was another phase of nothing for another 5 million years, right? And then it happened again, and it started to settle. And then over the last 600, 400, 200, there is no way of knowing how old that ice is. There is no way of knowing how old that ice is there? What are they going to compare it to, right? If Greenland had, I'm not sure how deep Greenland goes, but if they both dug the same amount, let's say Greenland's 3 k's, and they dug 3 k's here, 3 k's in Greenland, and everything was roughly the same. You could see the same stuff in the atmosphere, more or less, right? How can you prove what age the very bottom ice is? You can't. You can't. And to say they can, it's magic. You cannot prove it. It doesn't come with a timestamp, does it? There was only so much going on in those days, right? Dinosaur farts and volcanic eruptions. What else would there have been? Big wildfires from when lightning struck the brush, right? Because the whole place would have been green, you would have thought in certain places. Lightning, bang! Fire in the atmosphere. Then there could have been water eruptions with loads of moisture in the atmosphere and the heat like now. But why would that show up? Because it's heat. If there is heat, you're going to lose ice, aren't you? You're not going to gain ice. It's not going to it's not like a guaranteed hit, year 800,000 and then year 799,999 and then this is year 799,780. This is Christmas this year, December, look. How can it work like that? It's not like it snowed every single year for 800,000 years up until now, and now they're digging. And they go, oh yeah, look, we can see each layer, that's a year, that's a year, that's a year. What if between there and there it's 50,000 years because there was no ice, because it was too hot? How would they ever know? They would never know. So these ice cores, very limited information, unless of course there's magic involved, right? Magic. Where have we heard that before? Science, magic line. Otherwise, explain. It's all right agreeing, but it's not until you think about what is in this ice that is going to tell me all of this information that they keep getting. What is it that is in that ice? I get that there's bubbles of gases and that apparently freezes and it tells them what's in the makeup of the atmosphere. But in the makeup of the atmosphere, where this froze, not 50 kilometers away or 200 k's away or 3,000 k's away, in the atmosphere where this froze, right? It might have been different 200 meters down the road or 20 k's down the road, wouldn't it? Nah, honestly. And as for working out the speed of light, so tonight, when it gets dark, we have a quick one now, because this is set in stone, right? If a sun has a diameter of 3 millimeters, if we shrunk the sun down to 3 millimeters, right? There would be 108 sun diameters in between Earth and the sun. Can't be argued with. That's what they're telling us, 150 million kilometers. 1,390,000, divide one by the other, and we get 108 sun diameters in between us and the sun. That is 32.4 centimeters, right? So that nail and that nail, that's the sun, and that is 32.4 centimeters. Now, according to the science, and we don't need to scale the speed of light down or speed it up because it's smaller distance. The sun takes 4.6 seconds to radiate light the distance of its diameter. We would expect to see the light from here and go to there, and it takes 8 minutes and 20 seconds. That's scaled right down to a 3mm sun, right? If the sun turned off right now, here, right, and then we've got the word, right, the sun's going back on in about 10 seconds. And I stood here with this, right, and I put my finger there, and they go, right, they've just turned the sun on. If I went 4.6 seconds for each diameter of 3mm, it would take me 8 minutes and 20 seconds to get up to here. Bing! And then the lights would come on. The sun would shine us, and that would prove that it does take 8 minutes and 20 seconds. 4.6 seconds per diameter, right? So, to scale, right? The sun with a 3mm diameter will take 8 minutes and 20 seconds to radiate its light to Earth. This is perfectly to scale. Just that Earth would only have a diameter of 27 micrometers, 0.027 millimeters. All right, so we're going to have a quick look at that tonight, because it will take the sun 8 minutes and 20 seconds to radiate light to there, if the sun were just a 3mm bulb. Is that what we think of our sun? All right, peeps, laters.